Okay, so today we're going to continue our discussion of section 5.1. We're looking at different formulas. In the first video, we looked at interest-related problems. In this video, we're going to look at our two other types of problems, our velocity formula and our similar triangles. So our velocity formula is a physics-based formula. V equals the square root of 2gh. V is our velocity of the object. G is our acceleration due to gravity. On Earth, that acceleration due to gravity is 9.8 meters per second squared. And h is the height from which the object is dropped. So we're going to use this formula. For A, find the velocity in meters per second of an object dropped from 15 meters on the Earth. All right. So we are looking for our velocity. Right. So that is the value that we are looking for. Our G, right, is going to be this 9.8 meters per second squared because the problem is taking place on Earth. If I remember correctly, there is a question in your homework where you're not necessarily on Earth. You're talking about something happening either on the Mars or on the Moon, so your G might be different. But in this case, we're just going to use this value that's mentioned up here. All right. Our height is 15 meters. So we're going to use our formula. V equals the square root of 2 times 9.8. Oh, let's do 2gh in here, and then we'll show it being worked through. 2gh. So velocity is 2 times 9.8 times 15. Okay. If we go ahead and multiply that out, 2 times 9.8 times 15 gives us 294. And our square root of 294, we get 17.14. Velocity is labeled in just meters per second. So about 17 meters per second. In B, we're still going to use the same formula. An object hits the ground with a velocity of 15 meters per second. From what height was it dropped? Right. So now we have a velocity. Our velocity is 15. Our G is still going to be our 9.8 meters per second squared. But this time we are looking for the height. So V is the square root of 2gh. Right, V is 15. And we have 2 times 9.8 times h. We don't know our height. All right, we multiply our 2 times 9.8. We get 19.6. Right. In order to get rid of a square root, we square both sides. 15 squared gives us 225. On the right side of our equation, our square and square root cancel. So we just have 19.6h. Divide both sides by 19.6. H equals 11.48 meters. So our G is always labeled in meters per second squared. That's acceleration. Velocity is always going to be labeled in meters per second. And then our height is labeled in simple meters. Right, so there's a couple of application-based questions on our velocity formula that you will see in your homework as well. Then these last couple of examples that we're going to go through, we are going to talk about using proportions to solve similar shape problems. Similar shapes are shapes that have corresponding angles that are equal. and that the sides are in proportion to one another. So if we look at these two triangles, right, they're clearly different sizes, but notice that the angles, right, all appear to be the same. So when we're working through these problems, we're going to assume that that is true, and for a lot of these we're going to see little right triangles, and we're going to use those to set up our proportions. Right, so when we're setting up our proportions, if we look at these, we have pairs of corresponding sides. We have little a and big A, little b and big B, little c and big C, right, for our little triangle and our bigger triangle, our larger triangle. Right, so our proportion that we're going to set up is going to be using our A over B equals capital A over capital B. When you're setting up proportions, there are a couple of different ways that you can set up these proportions. We're just going to use this way. There are kind of alternate different ways of explaining it, but we're just going to stick with comparing our ratio of our little triangle to that of our larger triangle. Okay. All right, so if we look at example A, right, if we compare the sides of our smaller triangle, this side is 9, that side is 4. So for my smaller triangle, I'm going to write a fraction of 9 over 4. Right, for my larger triangle, the side that corresponds to 9, we don't know. That's what we're looking for. So we're going to have x over 20, because that's the one that corresponds to the bottom. We're going to cross multiply. 4x equals 180. Divide both sides by 4. X equals 45 feet. So the missing length of that triangle is 45 feet. For B, we're given an application type problem. On a sunny day, a tree casts a shadow of 25 feet. On the same day, a yardstick casts a shadow that is 2 feet 6 inches, or 2.5 feet. Use similar triangles to estimate the height of the tree. Okay, so we're going to start with a little picture for this one. So we're going to go ahead and draw out a picture. So this is going to be our tree. And we're told that this tree is the height that we are looking for. We are looking for the height of that tree. Well, this tree happens to create a shadow on the ground, which means that the sun is somewhere up here, right? And it's shining on the tree, and the tree's shadow is going to be down here on the ground. Right? This tree's shadow, we're told, is 25 feet. And now we're just going to kind of connect the dots here to get a triangle shape. Then we're told that a yardstick. So here's our yardstick. Our yardstick is 3 feet tall. Casts a shadow on the ground that's 2 feet 6 inches, or 2.5 feet. So again, we're going to connect that to give us a similar triangle shape. Now we can use our proportion to compare these values. So we're going to have little a over little b equals capital A over capital B from our larger triangle. So in our smaller triangle, we're going to have 3 over 2.5 equals x over 25. 2.5x equals 75. Again, by cross multiplying. Divide both sides by 2.5 so that it cancels. X turns out to be 30 feet. So the tree is 30 feet tall. Right, so a couple of application type questions in this section. Draw a little picture, sketch out a little triangle, make sure that all of your sides are matching up nicely in your similar triangles. Right, and that's going to wrap it up then for section 5.1.